Welcome back. Let's now create a table or two in our database and create the columns that go along with these tables. So right now I will assume that you have a database set up. I have one here called rack underscore test db2, and we have no tables in it right now. So let me get a fresh page going here so we can start working on the tables. Let's add our first table. So what we do is we highlight table here in the left column, left pane, and then I'll right click on it and hit create table, and this will give us a dialog box that pops up. So to start off, we'll give the table a name. By the way, once we start naming things, and this is really important to programming, you need to program in a way where your names aren't set in stone. You need to be able to continuously change your names as your application evolves. So considering that this is the first iteration we have going here, don't be too worried about what the name is, because we just go back and change it anyways. So let's go ahead and give this table a name. Let's call it Interstitials. Now let's pay close attention to the naming conventions I use. For one thing, I've ended it in an S to show that we have a collection of interstitials. Each row in this table will represent an instance of an interstitial, or one interstitial. So many rows means there's going to be many interstitials. Another thing I'll do to the name here is I want it to be unique, because within the application and throughout the components, the name interstitial is going to be thrown around, so there's going to be a few things named interstitial. So what we'll do is we want to make the name unique. So I like to namespace a lot of my objects here, so this is what we'll do with this one, is we'll give it a name spacing of t underscore, which means it's a table. Now this is a first iteration that we're doing here, so names can change, and that's great. You want it to. When you're building a scalable application, the best thing you can do to make the code readable and maintainable is to do a lot of frequent refactorings, plus a lot of iterations through the code, which makes it become better and better as time goes on, and as you refactor and refactor. You'll see a lot of what I mean as we get into the code part of it. But anyways, the point is that unique names are extremely important to maintainable code. So now that we have a name for the table, let's come down here and let's click on the columns tab. Look at this, MySQL Workbench automatically created a primary key. So it checked that that's a primary key, and it does not allow nulls. So that's fine, we'll just go with that. Now first off, let's add something that is going to be in every single table we make, and here's a convention for it. Just call it TS, it means timestamp, and give it a data type of timestamp, and that's it. When the table saves, it'll actually create a default over here. So what this means is that every time an insert goes into this table, the date of the insert will be added to this column. So we'll always know when something was inserted. And since we're thinking about tracking things, the next column will be user ID. I'll make that an integer. So we'll make this not null. We'll make the timestamp not null too. What that means is that it's essentially not optional. It must be there. So we'll have some columns that it will not be checked, and all that really means is that it's optional. You don't have to put an entry in, but we always have to have a user ID. We always have to have a timestamp. So click not null. And by the way, for the primary key, I noticed it didn't set the auto increment, so we want to do that for the primary key. If you got a PK, pretty much always you want it to auto increment, so we don't have to do inserts of the ID. The database does that for us. Now the reason that we have a user ID in here, just think about it for a second, is that regular users will not be putting interstitials in here. They won't be adding them to the system. Essentially, employees will, or administrators will. But we want to know who has been putting it in. I mean, has somebody from our marketing department been doing it, from our design department? Have we been doing it? We want to know who adds the interstitial. So this is what it tracks. Doesn't matter if you work for the company or if you are a customer of the company. Everybody who's able to log into the app has a user ID. Okay, next column, let's add a name for the interstitial. And we'll give it a varchar of 255 as a default. And it's not optional. There must always be a name, so we'll make it not null. Now another column that you'll find in almost every table you make, in not every one, but in a lot of them, is one we call enabled. I'll make it a tiny int, and it's not optional, so it must always be there. Enabled means just that we can turn it on and off. So you'll have an interstitial campaign, and you know it's enabled, and then so the application is using it. But at any point in time, we can disable it. That means it's not being used by the application, and it's not visible by the users. So we want to be able to hit a switch to toggle it on and off. So that leads to us wanting to give it a disabled date. The date time. I'll leave this unchecked because it is null. There will be no entry into it until the first time that it's disabled. And by the way, this will only hold the last disabled date, so you can enable it, disable it, enable it, disable it a number of times, but it'll only hold the last time that it's been disabled. However, we do want to know the history and the amount of times it's been enabled and disabled over time. So how we do that is we'll have a log table that tracks those. That just takes entries of the history of the enabling and disabling, but we won't worry about that in this iteration. So let us put in the corresponding enabled date. Now, by the way, let me mention here that enabled, though it seems like a bit, because it's either on or off, right? 1 or 2, but I always use tiny ints rather than the bit data type, because it just allows for more flexibility in case I need to expand with more states that it could be. And I find in most cases in real world applications, there are usually more than 2 states. There's 3 or 4. For example, there might be a enable state, a disable state. There might be like a pending state. There might be a pre-release state. So a few iterations down the road, you may find that these are requirements. So yeah, I always use tiny int for toggle type columns. Okay, for this first iteration, let's go with this for now for this table. So let me go ahead and hit the apply button. So it gives me this intermediate screen that shows me the actual SQL code. That's cool. I can even select it and copy it if I want to. Looks good. Let's hit apply. Script was successfully applied to the database. Awesome. Let's hit finish. Okay, let's close this table design window. Notice the database node here has a little arrow here. Let's hit it, and it opens up the table. There it is. Let's hit that little plus sign, and there's all our columns right there. So you've got a symbol for the primary key. These columns aren't ordered the way that I like them to be, but that can be changed. There's a script we can run to reorder these columns. But let's stop this video for now. We've made our first table. We'll go on to the second table in the next video. See you there.